We find the age of the universe by actually calculating backwards in time. We use the basic physics equation d equals v times t. And then we can rearrange that to say distance over velocity is equal to t. So if we can find distance and we can find velocity, we can figure out the age of the universe. In order to figure out the distance, we use an equation that states F equals L over 4 pi d squared. The F represents the apparent brightness, and L represents the actual. And the brightness of what? It's the brightness of supernova 1A. And these are just stars in our universe that we're able to calculate the distance of. So by finding the F of these supernovas, and L is actually a constant, we can figure out the distance that these stars are away from us. So once we have the distance that the supernova 1As are away from us, we need to find the velocity at which they're moving away from us. And the way we figure out the velocity at which they're moving away from us is using the Doppler and the redshift effect, which will be explained later in the PowerPoint. So once we have D and once we have V, we plot them on a graph of velocity over distance. And when plotted, they make a linear line going through the origin. And the slope of that line is Hubble's constant. So Hubble's constant is in terms of V over D. But we need this back in D over V. So if we take the inverse of Hubble's constant, we can actually find time. So time is equal to 1 over HO. So that is how we find the age of the universe, is doing the inverse of Hubble's constant.